So I want to talk to you about the definition of a derivative. You should have a worksheet in front of you, and the front of it has the definition of the derivative on it and 3 practice problems that we're going to do in this video. To find a derivative, we need to use this formula right here. It's called the definition of a derivative. You have the limit as h approaches 0 of f of x plus h minus f of x all over h. And you can see right away that if you substitute 0 in for h, you have a problem on the bottom, correct? Because you can't divide by 0. So our goal is to get rid of h. So let's try it with the function 4x minus 3. So you start by writing the limit as h approaches 0. I know it's tedious, but you want to make sure you write that on every single line so you know exactly what you're doing. First we have f of x plus h. So we're going to put x plus h into every x we see in our function. So it's 4 times x plus h, and then don't forget to subtract that 3. Next, we're going to subtract our entire function, and our function is 4x minus 3, and that is all over h. Your next step is to simplify. So we're going to distribute the 4 and get 4x plus 4h minus 3. And then distribute your negative, so you get a plus 3. And that is all over h. If I'm going too fast, feel free to pause the video at any time. You can also go back and you can try some on your own and then check my answer. Look at your numerator now. Your 3's are going to cancel and your 4x's cancel. Notice how my entire blue part canceled. F of x disappears. It cancels out. You want that to happen. If f of x does not cancel, maybe you forgot to distribute your negative. Always go back and check because f of x should always go away. Then we're left with 4h over h. What happens next? Yep, your h's cancel and you're left with your answer 4. So the derivative of your function 4x minus 3 is 4. Let's try another one. Let's try quadratic this time. So we're still going to do the same thing. The limit as h approaches 0. We're going to again have our f of x plus h. So you put x plus h in for every x you see. And in this one, there are 2 x's. Don't forget the plus 2. Then we're going to subtract our entire function. So we're going to subtract 3x squared minus 8x plus 2. Gets a little bit more complicated when you're dealing with a quadratic or a cubic or even a square root or fractions. All right. When you take x plus h squared, you have to FOIL it. So you're going to multiply your binomials first, outer, inner, last. There's also a shortcut. So if you take your first term, let's write down the 3 here so we have it. If you take your first term and square it, write that down. Take your x and your h, multiply them together, and then multiply by 2. So you get 2xh, and then you take your last term and square it. It's a little shortcut for FOILing. Then we're going to distribute our negative 8 and add our 2. With our function, we've got the negative, so we are subtracting all of this. So you're changing your signs, and that is all over h. Just writing it over there so to save us some room. Next, we're going to distribute our 3. Still want to expand it all out. Now hopefully, once it's all expanded, our function, that blue part, will all cancel out. So let's see if that works. 3x squared, 8h, and 2's cancel. Awesome. Now notice Oh, see, I knew I did something wrong. This is supposed to be an x so that this cancels out, because at this point in your step, every single term should have an h left in it. Okay, you've got an h, h, h. And that's how I knew that 8x didn't belong. All right, so every term has an h, so you are going to factor out an h. So you're left with 6x plus h minus 8. And that's all over h. Since we got rid of that h, that was our goal, we can now substitute 0 in for the remaining h's. So this h is going to go to 0. And we are left with 6x minus 8. So that's your derivative. That's your answer. All right, how are we doing? Let's do one more. We're going to throw a cube in here. Cube. All right. So it's the same process. You have the limit as h approaches 0 of 2x plus h cubed plus 5x plus h squared plus 4, and then you're going to subtract your entire function. And that is all over h. So I'm doing a cube with you because I want to talk to you about expanding out x plus h cubed. You can use Pascal's triangle. Have you ever done this before? It's called the binomial theorem. So Pascal's triangle starts with 1s, and then you add your diagonals. So you get 2 and 1s on the end. So the next row is going to be 1, 3, 3, 1. And then you get 1, 4, 6, 4, and 1. So Pascal's triangle actually gives you the coefficients of your binomial expansion. So we've got a cube, so we want to look at row 3. These are our coefficients. So we have 1, 3, 3, and 1. Take your first term, x. Start with your cube power. X cubed, x squared, x to the first, x to the 0. And then you take your next one, your h, and go the opposite way. H cubed, h squared, h to the first, h to the 0. Well, we know anything to the 0 power is just 1, so we don't need those. And we also know we don't need to write our little 1 coefficient. But what that gives us is x plus h cubed. Let's read it down. So we have 1x cubed plus 3x squared h plus 3xh squared plus h cubed. So you get the limit as h approaches 0 of 2 times all of this. Keep on going, and when you're done, you should get 6x squared plus 10x as your answer. See if you get it, and then finish up the worksheet. I'll talk to you later.